Okay, good evening, ladies and gentlemen. I am going to be talking about a subject. A lot of students hate this stuff, and they don't like radicals. They don't like to see square roots. They don't like factoring. So the thing is, my mantra has always been repetition is the key. The more you do it, the better you're going to get at it. Okay, so I have a boatload of questions. This is going to be pretty much, I don't know, I won't call it a long video, but long enough. But this is going to give you a step-by-step method or methodology for working with radicals, because people see them and they get scared. They see 2 plus 2 is 4, 1,000 times 3,000 is 4,000, and they don't worry. But when they see radicals, they kind of, oh, I don't want to deal with that. So let's jump right in. Practice, practice, practice makes perfect. Always remember that. So, your teacher gives you a problem, and let's see how that ink looks. That ink looks horrible. Don't like it. Not dark enough. Let's say your teacher, your instructor, whatever you want to call him or her. That's not very dark either, but we are going to press on here. Alright. Root 75. Square root of 75, and you look at that and you're like, oh man, I don't want to do this. Okay. So I'm going to give you a way to attack this problem. Square root of 75. We got to look at this and say, okay, what are some factors? What divided by what in the simple form? What divided by what equals 75? So we could say 1 and 75. We could say 2. Well, no, not 2. 2 doesn't work. Let's just say 3 and 25. We could say 5 and 5 and 7 one time. 15. But basically what I'm looking for out of all these numbers is I want something that's going to be a square root. Or something that reduces the square root of 25 equals 5. That's the number I'm looking for. It reduces into a simple number, right? 75, the square root of 75 does not. 1, if we squared that does not. 3 does not. 5 does not. 15 does not. So this is our best answer. But before I even go there, alright, we want to look at this as being (25) times 3 equals 75. Okay, I'm going to go real slow with this. So when we see the 75, oh, the scary radical sign, just think of the 75 as 25 times 3. Now what happens is, this could also be looked at as the square root of 25 times the square root of 3. And then we just break this down to 5 root 3. Not too bad, right? Not too bad. Let's try another one. We'll try another one. Let's say, and then sometimes they got the nerve to even put numbers outside of these little scary signs. Let's say they gave us 5 root 63. Well, they're together. So you have to look at this as 5 times, and again, the root of 63. And we got to think of, all right, what can we do with that? All right, so, and this is a really good reason why you need to kind of be aware of what your times table, because 9 times 7. 9 times 7 equals 63. So this is basically 5 times the square root of 9 times the square root of 7. Alright, real nice and slow, not too fast. So the square root of 9 is 3, so this will be 5 times 3 times the square root of 7, and wind up being 15 root 7 is our final answer. Not too bad, right? Again, let's take the square root of 72. Can we think of any numbers? And another thing what I like to do is, instead of saying 8 in front of 9, I know that this breaks down. If we square root it, it breaks down to something. So that number I like to put, because I know 9 is a multiple of 3 times 3, and it's going to reduce. The 8 is not going to reduce. So I like to put the 9, then the 8. Now again, this represents square root of 9 times the square root of 8. Okay, now interesting thing happens in this particular case. All right, the 9 reduces to a 3, and when we put these together, it's just like having a multiplication symbol. Don't get freaked out on me, but we have a 4 and a 2. All right, 2 times 4 is 8. So it would be 3 square root of 4 times the square root of 2. I'm sorry, I always do this. Alright, so because this reduces to a 2, so it would be 3 times 2 times square root of 2, and our answer would be 6 root 2. Alright, we do this all night, but I do it for you guys, because you guys want to be excellent mathematicians, and that's a beautiful thing. Now, let's do something funky. You know I always do that. I gotta throw something crazy out there, right? And you're like, damn. But you know, this basically makes your testing easier. We lift some heavy weights. If we just lifted 5 pounds, our mental muscles would never get stronger. I'm sorry. Z to the 10th power. Alright. Looks ugly, doesn't it? You're like, damn. I'm probably like the most down-to-earth tutor, instructor, or whatever you want to, I'm just like, I'm straight up. I know what this looks like when you look at it. And your teachers are like, oh, we expect you to get this, study hard, but it takes time. Repetition. Alright, so our -5 is out here. We have our radical sign, and we will say this is 9 times 2. That represents the 18, and then we have our x to the 4th. Let's make it small. Y to the 6th power, z to the 10th power. And I'm going to show you what goes on with all that. But basically this is just like saying 5, square root of 9, square root of 2, square root of x to the 4th, times the square root of y to the 6th, times the square root of z to the 10th power. And we break this down. We work everything individually. This is going to be -5. This breaks down into 3, because 3 times 3 represents square root of 9 is 3, because 3 times 3 equals 9. We can't do anything with the 2. Now, something very interesting is about to happen. All right. The square root of 2 is going to stay inside the radical sign. So this is going to be -15. And what's going to happen is, with these individual variables that have exponents assigned to them, some division is going to happen. Now this is a square root. When we see a square root symbol, just think of a 2 as being there. We just don't put it there, but it's there. So what we're going to do is we're going to take the exponent, we're going to divide it by 2, however many times it divides by 2. The remainder is going to be left in the radical sign, in the radical symbol. So if it divides evenly, then it's going to totally come out. So let's say if we had x squared in there, x squared would just come out. And I know we're going to do a bunch of these, so just bear with me, but just think of the square root symbol. So we're going to say 4 divided by 2 this is a square root symbol. So we're going to say 4 divided by 2 is 2. So x squared is going to come out. There's nothing remaining. Y to the 6 divided by 2 equals 3. Y cubed. And everything actually is going to come out except the 2. The 2 is actually going to stay in there. And then z10 is z to the 5th. So let's see how much real estate. Our final answer is 15 x squared y to the 3rd z to the 5th root 2. I know, I told you that was going to be nasty. But really, it's really not that bad. It's just when you work with everything in here, and we're going to do another one similar to this, but see how much real estate I got. That line, okay. Because now it's getting a little hectic. Remember, when we see the square root sign, there is a 2. Looks like we can't see that now, can we? We'll come down. There's a, see square root sign, there is a 2. That's why we call it a square root. If it was a 3, it would be a cubed root. We also could describe this as an nth root because we could plug any number in and that's what it's going to be to raise to. But this is a square root. Another fun one. We have 20 x to the 5th, y to the 9th, and z to the 6th. Alright, now this is going to be interesting. Remember, looking at the number, radical sign, 4 times 5. You have x to the 5th, y to the 9th, z to the 6th. Okay, now, this is just like saying square root of 4 times the square root of 5 times x to the 5th, y to the 9th, z to the 6th. Now you can look at it like that or, you know, whatever, but this basically becomes 2 root 5. It's going to be 2 root 5. But now we have to work with these variables with exponents assigned to them. So we're going to have to make some space. Our 2 is going to come out because we have to make space. Now we got to look at the x. 5 divided by 2 is what? Goes in, 2 goes into 5 how many times? Twice. So x squared comes out. But there's remainder 1, so x stays in. 2 can go into 9 how many times? 4 times. So we would have y to the 4th. 1 remains. Alright, so a y remains. And then 2 can go into 6 how many times? 2 can go into 6 how many times? 3 times. So z3. That determines our what comes out. Alright. So our final answer is 2x squared y to the 4th, z to the 3rd, radical symbol 5xy. And it will not get it won't get crazier than that. I go crazy because I want you to just see how, you know, when you're in that test you get nervous, how to stop and be like, you know what? Let's just break everything down. And boom. So now that's as hard as it will get for you. Unless your teacher's like crazy. And I'm not saying they don't exist, because I know they're out there. 245. Alright, now, one thing I like to do when I am working with a whole bunch of radicals is I like to just, I like to do, I'll put a little table to the side here. Alright, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared. Alright, and these numbers yield totals. X squared equals 1, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, 5 squared 25, when I say squared, I mean 6 squared is 6 times 6, 36. 7 squared, 49. 8 squared, 64. 9 squared is 81. Alright. Just to give me a baseline of what to work with, because when you see this number, it's like, God, I don't know what the hell to work with this. I don't know how to work with this. So what I'll do is I'll take a regular calculator and I will say, okay, let's take 245 divided by 64, and I'll see if it gives me a whole number, because on most tests you can use your calculator. So let's just say I took my calculator and I plugged in 245 divided by 64. It would actually give me a number 3.8. I don't want that. I hate that. I need a nice whole number. So at this point, not knowing what you're doing, you're going to be playing with these numbers, trying to figure it out. And this is just an easy, foolproof way. So now I'll take 245 again. And I divide it by 49. When I do that, my result is going to be 5. So that lets me know, when I divide it by 49, this is a product of 49 and 5. Alright, and these are basic reference numbers that we will I might start at 245, okay. Divide this number under the radical by 81. I want to come up with a whole number. When I got 64, that didn't work. When I divided by 49, my result was 5 in my calculator. So I know that 49 times 5 equals 245. Alright? So that's how I get started. And it's cool because if we square it, we know that this is square root. The square root of this number is 7. So it helps me out in my problem, because now I already know this automatically comes out 7 root 5. Again, if I need to go back, this is because 49, this is basically 49 times the square root of 49 times square root of 5. Square root of 49 is 7, and the 7, this changes to 7 root 5. Okay, final answer. Again, square root 125. Alright. You could play with this all you want, but normally when I look at this and I'll be like, okay, well, there's 25 in the number. Okay, so I know that this is a multiple of 25. So I'd start out there. Alright, because I say multiple of 25 because 25 times 25, 25, 25, 25. Alright, 125. Those are our numbers. So 25 times 5 is equal to 125. So under my square root simplification, I could say 25 times 5, or root 25 times root 5. This breaks down to 5. Final answer. Okay, let's say 196. And again, when we see 196, we just start at 8. 196 divided by 81. See if we get the whole number. That won't work. 196 divided by 64 will not work. 49 divided by 196 divided by 49. When you do that, you're going to come up with a 4. Alright, so we're going to get root 49 times root 4. Okay, now this is just going to break down into 7. This is going to break down into 2. And the answer is 14. Alright, so the square root of 196 equals it reduces or simplifies into 4. The square root of 196 was the product of root 49 and root. So we can't say, oh, this is what it simplifies to. But if I take 14 squared, 14 times 14, and I love using my it's not gonna. Well, it might. Hold on. Let's look at square root 196 simplifies to 14. And to test it out, I like to use my rapid math method. 10 is a reference number. Plus 4 plus 4. 14 plus 4 equals 1, 8. Reference number 10. Add 0. 4 plus 4 is 8. Oh, I'm sorry. Yeah, 180. No, 4 times 4 is 16. My bad. I forgot my own method. Alright, so 14 squared equals 196. Alright. Moving right along. Let's look at the square root of 12. Look at the square root of 12. Root 4 times root 3. This breaks down into a 2. Final answer 2 root 3. $72. Root 9, root 8. 8 times 9 equals 72. This breaks down to a 3. 3 root 8 is our final answer. Nope, I said 3 root 8. Not true. 3 root 8 is actually root 4 times root 2. 3 times 2 root 4. And that's 6 square root of 4. And that can't be. I went way too fast with that. Square root of 12. Try this again. Root 4 times root 3. Did I do that one already? I think I did, yeah. I'll break it down. I won't stop. I'll just keep going. Root 4 times root 3. That comes down to 2 root 3. Yeah, it was no use in me stopping in the middle. I might as well just completed it. Alright, root 72. That was the problem. It was root 9 times root 8. This does become a 3. This becomes a root 4 times 2. 3 square root of 4 is 2 root 2. 6 root 2 is the answer. Sometimes I move a little bit too fast. Alright, let's say we have a question to simplify 3 root 12. Well, the 3, it just stays out of the fight for now. And we have root 4 times root 3. 3 square root of 4 is 2 times root 3. 6 root 3. Final answer. Trying to find another good question. Yeah, that's nice. 6 root 128. Let's simplify that. Okay, so again, we would go to our table that we made off our squares table, and we'd say 128 divided by 81. You get a number in decimals. You come to 64. 128 divided by 64. You would get a 2. Alright, so 6, 64 times 2. Ratio drops. This is just like saying the square root of 64 times the square root of 2. 6 square root of 64 is 8. 48 root 2 is our final answer. Well, I got loads and loads. I'm going to keep going. Let's see what happens when we get a negative. Negative 8. 392. Now, you may have a different way of coming up with your factors, but I like this because it's easy to remember. Square 1 through 9. And if you get nervous, this is much easier to remember. Alright, so we break down, we say 392 divided by 8, we get a decimal. 392 divided by 8, we get a decimal. And then we would divide 392 by 49, and then we would come up with a whole number in our calculator. That number would be 8. So we know that 392 is 49 times 8. Now, again, this is just like saying root 49 times root 8. Negative 8, this becomes 7, and this can be reduced further because 4 times 2, so negative 8 times 7 times 2, root 2. 8 times 7 is 56, and so we'd have actually negative 56. We double that, and that would be actually negative 56 and 2 is negative 112 root 2 for our final answer. So that was a little ugly, but not too bad. I think you guys are getting down how the table works when we get bigger numbers. And let's say they put in a variable, like say it's square root of 192n. Well, this n is not going anywhere because there's no exponents assigned to it. It's going to stay within the radical sign. Now the only thing we have to work out is the division. So 192 divided 81 gives us a whole number, a decimal number. 192 divided by 64 gives us a decimal number. And then, actually, I'm sorry, it does not. When we divide 192 by 64, we will get a 3 as a result. So 192 would equal, would be the product of 64 and 3. Cool thing about this is, and the n is in there, so don't forget about that n and bring it down. But this would be 8 root 3 n as a final answer. So now what we're going to be doing is implementing variables inside our answer. So 196 v2, and there's a square root sign there. So $196. Did we have 196 before? Not sure. Look, 196 divided by 81 gives us a decimal number. 196 divided by 64 gives us a decimal number. And then 196 divided by 49 gives us a 4 in the calculator. So we know that 49 times 4 is equal to 196, and our v squared is still there. So now, at this point, we know that, like I said, this is just like saying square root of 49, square root of 4, I don't know why I was writing 2, times square root of v2. Something very interesting happens. The 7 comes out, or not comes out, but square root of 49 is 7. Times the square root of 4 equals 2. And since this, whenever we see a square root, we think of it as a 2, and we think to ourselves, now this is 14. How many times does 2 go into 2? 1 time. So we'll just put a v there because the 1 is assumed to be there, and that's our final answer. 14v is in Victor. 14v. Alright, so we are getting them a little bit more challenging and harder. 252. And dude, once you go through this video, if you need help, you should need help. That's why I make these videos like this. I try to make them thorough, throw a lot of different situations at you. 252x squared. Alright. Again, 252 divided by 81 gives us a decimal. 252 divided by 64 gives us a decimal. 252 divided by 49 gives us a decimal. We don't get a whole number till we divide 252 by 36. That whole number in the calculator. If we put 252 divided by 36, the result number we're going to get is a 7. So that tells us 36, 7, and again we put the x squared in there. This comes out 6 root 7, but the x squared comes out because how many times does 2 go into 2? One time. So 6x root 7 is our answer. Okay, I want to go to something a little bit more interesting, because I think we beat that to death. I think you guys have that concept down at this point, or you should. Yeah, there we go. Oh yeah, you guys know I was going to turn up the heat. You know I was going to turn up the heat. Yeah. Let's try not so... Alright. Square root of 72. A3 b to the 4th. Okay, this is just like saying the square root of 9. Square root of 8. Adding times 8 is 7. And then we have a to the 3rd power, b to the 4th. And that's under the square root symbol. The 9 is becoming 3. And we're going to have root 8. But now we must deal with this part of our question. So 3 is going to be here. How many times does 3 go into 2 go into 3? One time. So A is going to come out. And A is going to remain under the radical symbol. How many times does 2 go into 4? 2 times. So B squared comes out. And that is our answer. The 8 just comes down. The 8's not going anywhere. 8 stays in. Alright, so our final answer is 3a b squared and square root 8a. That is our final answer. Okay. Trying to find another interesting one. Yeah, I like that. Alright. 512. 512. M to the 4th, N to the 3rd power. Okay, so again, we go to our table. I don't even know, let's see here. I'm actually going to have to do this by hand. Alright, no problem. Because I thought I had my notes for this, but we're going to divide 512 by 81 and see what we get. 81. I know it's not going to work. Let's see. 512 divided by 81. 6.32 is our answer. This will be the last one too. But 512 divided by 81. Our answer is 6.32. So then we say 512 divided by 64. that gives us an 8. So we know 64 times 8 equals 512. So 64 times 8, and then we have our m to the 4th, n to the 3rd. Alright. So this just becomes 8. It's hanging out. The 8 is going to stay in there. And no, actually it's not going to stay in there because we can do some stuff with that. So we could have 4 times 2. And the square root 4 square root 2. So it'll be 8 times 2 root 2. And then we work with the m, 4, and 3. So this is basically 16 root 2. So we see what stays in the radical, what comes out. Remember, there's a 2 here. So how many times does 2 go into 4? 2. So it would be 16 m squared. And how many times does 2 go into 3? Once. So we put 1 in out here, square root symbol, 2. Am I getting all that? I may not be getting all that. So let me just break this down. Five, 12, m to the 4th, n3 becomes 16 to m squared n square root 2n. Okay. 2 went into 4 2 times, so m squared comes out when we're working with the radicals. And 2 goes into n to the 3rd, 2 goes into 3 1 time, indicated here. Remainder 1, the remainder stay in here. And the 2 just stays in there, so 8 times 2 is 16, m squared n square root 2n. Okay, so I guess you guys got the gist of that. It's a little tough, but like I said, rewind. You can always start from the beginning and just stop, walk yourself through it. But repetition is the only way you're going to get this. It's not going to come to you like, boom, I can't pour it in your head. Practice is the key. If you still don't get it, give me a call because I offer tutoring. So that's it. Thanks for watching my video. Take care.